Welcome to the video on distance. Unlike the other topics that we've looked at so far, distance is the first topic which is really brand new. It doesn't represent prior understanding or knowledge from your middle school years. And just as a reminder, if I say something in the video that you don't understand, you do need to take a minute to pause the video, rewind it, and listen again to that piece that didn't make sense the first time. If at that point you still don't understand, jot yourself a note in the margin so that you can remember to ask me about it the next time that you come back to class, or even shoot me a quick email so that I know to expect your question when you come into class tomorrow. All right, so in example 1, they're asking us to find the distance between the 2 points whose coordinates are -2, 1 and 4, 3. And so that I have a good feel for exactly what it is I'm being asked to do here, I'm going to begin by going ahead and plotting those points. So that first green point represents the point whose coordinates are -2, 1. And the second green dot represents the point whose coordinates are 4, 3. You might say that the distance between those 2 points is the same thing as the length of the line segment that joins those 2 points. So kind of a key idea, distance and length are really the same idea. So sometimes you'll be asked for distance, sometimes you'll be asked for length. Now, because the line segment that joins those 2 green points is slanted, I can't simply count the number of boxes in between the 2 green points. What I can do is I can sketch in a triangle that happens to be a right triangle with a horizontal side and a vertical side. And now, if I want to find the length of the line segment that joins those 2 green dots or green points, notice that that line segment is actually the hypotenuse of my right triangle. So I can find the length of that hypotenuse, or the distance between those 2 green points, just simply by doing Pythagorean theorem. So this leg here is 2 units long. This leg here is 6 units long. The hypotenuse I'm going to call x. So the first leg, 6 squared, plus the second leg, 2 squared, has to be equal to the length of the hypotenuse squared, or in other words, x squared. And now I can either say, well, 6 squared is 36, 2 squared is 4, so 36 plus 4 is 40, or I can go to my calculator and I can simply type into my calculator, and in order to do this, I want to go open up a new document. I don't want to save the old document. I'll add a calculator, and I simply want to do 6 squared plus 2 squared. And my calculator will do all this calculating for me in one single step. So now 40 is equal to x squared. And I'm now going to take the square root of both sides. So x is either equal to the positive or the negative square root of 40. Now, because x represents a side of our triangle, we can't have a side of a triangle with negative length. So I'm going to keep the positive square root. Now, you might be wondering what to do with that square root. Do you round it to the nearest tenth? Do you leave it as it is? Should you simplify that square root like you learned to do last year in algebra class? And the answer to that is we are always going to leave these distances in simplest square root form unless we're told to find to the nearest tenth or the nearest integer, or to round it in some other way. So the question, notice, doesn't say find this in simplest square root form, but you have to know that if no other directions are given, we'll always find this length in simplest square root form. So a quick little review on how to simplify radicals. 40 is not a perfect square, but it has a couple factors that are. 4 is the largest factor that'll go in there, or the largest perfect square factor that will go in there. It'll go in there exactly 10 times. So the square root of 4 is 2. Square root of 10 is not a perfect square, and we can't take its square root, so it just kind of comes along for the ride. And therefore, the distance between those 2 points, or the length of that line segment, is 2 square roots of 10. Now, we did that very nicely by drawing a picture in doing the Pythagorean theorem. But what if I posed this question to you? What if we wanted to find the length between 2 points or the distance between 2 points without having to go to the trouble of doing that in a graph? And for finding distance without having a graph or using a graph, we have what's called a distance formula, or the distance formula. And the distance formula says that the distance between any 2 points, or the length of the line segment that joins any 2 points, is going to be equal to the square root of the difference between the two x's, so x subscript 2 subtract x subscript 1 squared, plus the second y subtract the first y squared. And if you're thinking this looks like a little bit like the Pythagorean theorem because of all the squared terms in it, you're absolutely right. The distance formula is a relative, maybe a child or a grandchild of the Pythagorean theorem. So now, these two guys represent our first x and our first y. These two guys represent our second x and our second y. So now I can go ahead and plug in to my distance formula, and I'm going to solve the same problem using a different method. So my second x subtract my first x, 4 subtract negative 2. And then my second y subtract my first y, 3 subtract 1. And I want to square that difference. And when I go to plug this into my calculator, I'm going to plug in everything underneath the square root sign, but not the square root sign itself. So I'm going to begin with that very first open parentheses. So open parentheses, I've got the 4 subtract the negative 2. And I want to take that entire expression that's within the parentheses and I want to square it. So I make sure the squared goes on the outside of my parentheses. To that, I want to add the difference between 3 and 1. And I want to take that difference that's inside the parentheses and square it. And again, I square the whole term inside the parentheses. And that tells me, as I would expect, that the answer is 40. Because we haven't taken any square roots yet, our 40 is still underneath the square root symbol. So notice that we ended up with the exact same answer that we got when we did this via the Pythagorean theorem. And this will simplify exactly the same way. So now you've got a couple different strategies that you can use in order to find length or to find distance. You've got the Pythagorean theorem, which involves the work on the graph. Or if you're not such a visual person and you want to use the formula, now you've got the formula that you can use. All right, I'm going to move on to number 2. It says find all points whose coordinates are 10, y that are 13 units away from the point -2, -1. That 13 units represents distance or length. So because this is a question involving distance, I'm going to go back to my distance formula. Anytime I want to use a formula, I'm always going to write it down first. So the very first thing I'm going to do is begin by writing that distance formula down. You need to write the distance formula on your paper as well. And then I'm going to go plug in to my formula all of the terms that I know. This question is different than the first one because in this question we know the distance is 13. So in for distance, I'm going to substitute 13. My second x is -2. My first x is 10. And I want to take that difference and I want to square it. My second y is -1. My first y is y. And I want to take that difference and again I want to square it. I'm going to clean up a little bit what's inside the parentheses. The only thing that I can simplify inside the parentheses is that -2 subtract 10. So I'm either going to use a little bit of mental math or I'm going to simplify on my calculator. I know -2 subtract 10 is -12. And I want to take that -12 and square it. This guy, because the -1 and the -y are not like terms, there's not a whole lot I can do with that right now. Still working inside or underneath the square root symbol, I want to take that -12 and I want to raise it to the second power. I want to square it. So again, I can either employ a little bit of mental math or I can say I know that -12 squared is 144. And now I'm at the point where I can't do anything further to simplify what's underneath the square root sign. So now I really need to get rid of that square root sign. And the way that I'm going to get rid of that square root sign is by squaring both sides of my equation. So if I take the 13 and square it, I end up with 169. And again, I did that mentally, but if you need to check that on your calculator, you check that on your calculator. When I square the right side, the nice thing about squaring the right side is that squaring and square rooting are inverse operations and they undo one another. So in other words, by squaring that, the square root sign goes away. So 144 plus -1 subtract y squared. To undo an adding 144, I'm going to subtract 144, and if I do that from the right side, I have to do that from the left side as well. So that tells me now that 25 is equal to -1 subtract y, quantity squared. And now, to undo squaring this term, I'm going to take square roots. So again, squaring and square rooting, they're inverse operations. They'll undo one another. But if I take the square root of the right side, I have to take the square root of the left side as well, remembering that every square root has both a positive and a negative value. So square root of 25 is 5. The square root and the squaring undo one another, and I'm just left with -1 subtract y. I'm going to go ahead and add 1 to both sides. So on the left side, I end up with 1 plus or minus 5. On the right side, a -1 and a +1 are 0, so I end up with -y. And I think I'm going to go ahead and solve this equation for -y. So 1 plus 5 is equal to -y, or in other words, 6 is equal to a -y, or a -1 subtract 5, or -4 is equal to -y. Now if 6 is equal to a -y, then y must be equal to a -6, or y can be equal to a 4. All right, in the interest of time, I'm going to stop there. We'll talk more about number 3 when you come back to class, although if you wanted to give yourself a good challenge, you could take a look at that one. I do want you to do for tomorrow, fill in the top of page 10 where it asks for the key ideas and important understandings. And these I want you to summarize in your own words. Did you really get out of this video what you need to get out of it, what you need to be able to understand? And then you can go ahead and see if you can apply what you've learned in this video to answer questions 2, 3, and 4. Thank you for the gift of your time. And as always, if you have questions, feel free to write them down. Feel free to email me with them.